Good morning, good afternoon, good evening, depending upon your time zone. And welcome back to the DCA Forum Day 3. At this point, I'd like to introduce Michael Gruninger from the University of Toronto. He's a highly accomplished ontologist, been working formally in this area for over 25 years, and is the former president of the International Association of Ontology and is a founding member. Take it away, Mike.
Thank you, Steve. And thank you very much for the opportunity to present some of the latest ideas that we've been looking at in our experiences with applying ontologies in enterprises. This is incorporating some work from other members of my Semantic Technologies lab, including Carmen Shui, Ming Shi, Megan Katsumi, and Ali Hashemi. So let's begin with kind of the primary challenge that we are facing today. And I think the two key words that you can take away from this are integration and interoperability. In many different applications within an enterprise, we are striving to bring systems and people together. If you're talking about software systems, then these software systems need to be able to exchange information between them in such a way that the meanings of those messages are preserved. Or alternatively, you can think of taking many different data sets from many different sources and trying to pull them together and make sense of all that data, right? One of the challenges being when we pull this data together, what does this data really mean? And can we actually use it together, right? So as an example, very common example right now, say with COVID testing. If a jurisdiction is releasing the number of COVID tests done in a day or done in a week, say, does that include individual tests, or does that really mean different people who are being tested, who could have been tested multiple times during a week? So you have this kind of potential clash of the meaning of what is a test when you're bringing data sets together. See, the challenge here, though, is that this semantic heterogeneity, different applications, different databases, different agents can ascribe different meanings to the same term. You know, for example, what is a test? Or they may use distinct terms to convey the same kind of meaning. So it could be, you know, test in one data set, and it could be diagnostic test in another data set. It was the same thing, right? Not sure. Different strings. Are they the same things? So what we are trying to do then so then our motivation here on the next slide is that ontologies have been promoted as a means to support this integration and decision support. Now, in the past, the focus has been on the impact that ontologies have on an enterprise's information systems. And so we can see following this that a particular sort of scenario that can arise when we're dealing with this. So this is an example of interoperability software integration among 4 different business process modeling tools. So you can have the ProSim tool from KBSI that uses IDEF3 as its process modeling formalism. You can have, say, some Magic Draw dealing with UML. I could have some BPMN tools for the business process modeling notation, or I could just simply have some data flow diagrams that are done just using a drawing program. Now, each of these software applications is implicitly using information about processes. And they're going to use similar terms: process, event, task. Do those really mean the same thing across all of those? See, the idea would be that if someone in an enterprise, you got different units within this enterprise that are actually using different software tools. Or you could imagine partners of an enterprise, each using their own software tool, and they want to be able to collaborate, say, on a virtual enterprise sort of application. So ideally, what you would want to have would be, different groups designing business processes and then sharing them with others, right? Now, in this particular sort of example, people often, say, conform their ideas, their semantic intuitions about a particular domain with whatever tool they're using, or they assume that the tool's intended semantics for particular terms corresponds to the intended semantics they have in their head. So that's kind of another sort of challenge, right, that we have when we are, kind of dealing with this. But today I want to maybe focus, I mean, I will have this sort of some examples illustrating this. But what I want to do today is illustrate something a little bit different. And so on the next slide, we have the kind of the overview of what I want to talk about today. I actually want to focus a little bit more, not just on how software can be integrated by using different kinds of semantic technologies, but how semantic technologies like ontologies can shape and also be shaped by the perceptions and behaviors of people within the enterprise. So I want to draw a little more attention to the role that ontologies can play to help people, and indirectly the software that they're using. So there's sort of this kind of symbiotic relationship between our internal ontologies for different concepts and the implicit ontologies of the software we use. But I kind of want to draw that out a little bit more. So I will be covering sort of these 6 kind of ideas over the next 25 minutes or so. First, we'll look at some responses to this problem of semantic heterogeneity, how people have dealt with it in the past, and in a lot of cases are still dealing with it and now. And I'll kind of pitch a slogan that I often use, this idea of diversity without divergence, how ontologies can help support this kind of interoperability in a very different way than we've seen in the past. Now, this will rely on a couple of other techniques. First of all, how we can design ontologies by reusing. So very often people are building ontologies in isolation and without thinking about reuse and shareability. But also then that whole challenge of how do we acquire these ontologies in the first place, right? And what kind of techniques can we use to support a more efficient design of ontologies? Now, once these ontologies have been built, right, now we have this promise of semantic integration. And again, if you put a lot of effort into actually designing ontology, what's the return on our investment there? And I'll have a few ideas and thoughts about that. And then I'll wrap up with what kind of skills do we actually need? So if we kind of want to use ontologies to empower people to identify and codify their intended semantics, what skills do they need to do in order to really benefit and deliver the benefits of ontologies? Okay, so let's kind of begin then into the technical meat of the talk. So we're going to be looking again at this responses to semantic heterogeneity. And I'm going to have these 2 kinds of ways of looking at this. Now, initially the scenario, I have Alice and Bob, right? And Alice is asking, which active clients have fixed term mortgages and original household income above $500,000? And Bob says, what are you talking about? Right now, of course, like I mentioned before, there's this kind of symbiotic relationship between agents, actors, and the software they use. So on this slide, we have, Alice and Bob talking to each other. But on the next slide, you can see what actually is going on, right, is that Alice's software system is talking to Bob's software system. And so these aren't natural language questions that are being passed back and forth. These are typically different information modeling languages are being used. And on this slide, you can see, one of these is XML, and another one is Express. Express is an information modeling language. It's part of ISO 10303, otherwise known as STEP, the Standard for the Exchange of Product Data. So this is actually what's going on in terms of the software, right? So Alice and Bob are trying to communicate with each other, and maybe they don't understand each other at that level. But at this other level, their information systems aren't able to communicate with each other because they're using different syntaxes. Okay, so how do people deal with this? Well, one approach that we can see on the following slide is to standardize the syntax, right? So the idea is that, XML is one syntax, Express is another syntax. You see, your whole problem here, you guys are using different syntaxes. Just use the same syntax, your problems will be solved. Now, I call this the XML illusion in a way. I mean, because XML, using on the semantic web, XML has kind of rapidly been kind of adopted to be, the standard syntax for these languages, which is, necessary. But the problem, I call it the XML illusion because it's kind of believed that the problem will be solved if everyone just uses the same syntax, right, and the same terminology. And in fact, from the original W3C document for XML, right, it states that XML makes it possible to tag the contents of a web page using, emphasis here, meaning indicating properties. That was the promise, right? The problem, of course, is that even if everyone uses the same terms, right, the problems with specification of those terms is still a problem, right? So we can see another example where, you know what I mean, right? Let's take something like a purchase order. A purchase order, I'm going to have some standard tags here, a product, a date, and a price. Now, let's consider date. And I'm not here talking about the format of the date, is it month, day, year, month, day, whatever. But I'm talking about what date are you talking about? Is this the date that I received the order? Is this the date that I promise the order will be fulfilled on your end? Or is this the date that I ship the product out of my warehouse? Right now, if Alice and Bob disagree on what that meaning of date is, there's going to be a lot of problems because Bob's shipments might be late from Alice's perspective because she interpreted that date as being, this is the date you promised I would get it. And Bob says, no, this is the date I received the order. Other common things like, say, price, right? Is this, what currency is it in? Does it include any local jurisdictional taxes, a value-added tax, for example? Does it include shipping? Or is there free shipping, et cetera, right? And so just having the same tags alone doesn't give us any kind of guarantee. Okay, so then how do people respond to this? Well, approach they would say is, let's try to standardize the terms, right? And so there's a lot of effort involved in actually standardizing terms in terms of, say, for example, ISO, right? So we can develop standardized vocabularies, and the idea is you get people together, they have arguments, and they say, okay, let's arrive at a particular kind of meaning for these terms. And so just as an example, there's this ISO standard 15944, the business operational view, and this is supposed to support interoperability among different enterprises using OpenEDI. Okay, that's one approach, but what happens if we try that? See, the problem is that there actually there's a problem now with integrating these standards, right? So since the specification of the semantics is informal, there's still a barrier to interoperability, right? And we can see on the next slide that there are at least 6 other standards, 6 other ISO standards that all contain the term product, for example. Now, this is even within ISO. Forget, I'm kind of ignoring all the other kind of array of standards that you can access over the web. All 6 of these are ISO standards, and they're all, again, very recent, relatively recent here. They all have the word product. Do they all mean the same thing? So even though we have these standards, we still have now this problem of integrating the standards. Okay, so what we have now, we have this problem where there are 2 ends of a spectrum, right? Either you enforce, kind of a complete global agreement on terms and their meaning, or at the other end of the spectrum, you have no agreement whatsoever, effectively kind of semantic anarchy, which is, to a great extent what happens, still today. So how do we deal with this? How can we somehow have the kind of consensus where we can approach where we can capture consensus, but at the still time be flexible enough to identify what other kinds of relationship there can be? So a third approach, and that's kind of the focus for today, and to my research in a great extent, is to use ontologies, right? Now, there's a lot of different definitions of ontologies, but let's just kind of take an ontology to be some declaration of the terminology that you're using, together with some way of specifying the meanings of those terms, right? And so this can take a wide variety of forms. I'm not going to get into that today, but the idea being, like just if you took a UML class diagram, for example, there's terminology there. There's the classes that you have, and there are different associations between object instances of those classes. And there's a way of specifying the meanings of these terms, right? You can have a taxonomy. You can identify taxonomy there. You can specify different kinds of constraints. For every course, there must exist at least 1 professor. Every professor teaches at most 5 courses. These kinds of constraints. So you can think of an ontology as doing that, right? The thing though is, how does this actually help us with the integration of these systems, right? How do we deal with a potential clash of semantics? In particular, what if there are multiple possible ontologies for a given set of terms, right? And that's what I'm going to be addressing here with my little slogan here, diversity without divergence. So the idea would be, how can we maintain kind of a multiple set of ontologies that can work together? See, because one of the reflexes that people have when you're dealing with multiple ontologies is to say, kind of take the standardization route and to say, look, if you just use my ontology, all your problems will be solved, right? Don't use multiple ontologies, just use the one that I'm providing you, right? So that's still that one kind of option. But that really is not flexible enough, right? Because what we have found in practice is that even within the same enterprise, different people and different groups will actually have a different set of intended semantics for these different terms, right? And it's not the case that, oh, these people are mistaken, right? That if Alice has this definition of what a product is and Bob has this definition of what a product is, maybe they're both mistaken. They should be using a better definition, right? Or that is that they're that maybe Alice has the right definition, right? That's not what I want to get at here, right? So just take as an example, like, what is an event, right? Does an event have a duration, or is it considered to be instantaneous? Is an event always primitive, or does it allow decomposition, right? Is an event something that kind of occurs externally to someone's particular plan, but it occurs during it? Are events activities, or the occurrences of activities? You can see, just going, we think back, we don't have to go back to that slide, but just think back to that slide where we had the business process modeling tools. Like, each of those systems will have a different answer to those questions. But even within the same enterprise, right, Alice and Bob, may have different ideas of what an event is. And it's not like one of them is right and one of them is wrong, right? They may actually say, like, no, this is the way, like in my applications, this is what an event is. And you're not going to be able to kind of impose a definition on either Alice or Bob without kind of causing some sort of damage somewhere else within the enterprise, because they are building software based on that notion of event, or they're using software with that notion of event. So you're not going to be able to kind of force people to kind of all agree on the same term. And another example of this that I don't have a slide for, but as another example of this, a financial institution has a notion of an active client. Now, what is an active client, right? Is an active client someone who has an account that has a non-zero balance, even though they haven't used it for a year? Or is an active client someone who has transactions every 24 hours, for example? Depending on the different part of the enterprise of that financial institution, they will have different answers to that, and they will be building their data models appropriately, right? So how can we use this together, right? And that's, again, this idea of diversity without divergence. And that's kind of, in a way, what we want to do is what we've been doing in our Semantic Technologies lab is, using an ontology repository, we can actually maintain multiple ontologies while understanding the similarities and differences. And that means that if you and I can now have different semantics for terms, as long as we are identifying where we're explicitly agreeing on what we agree on, allowing each other to be different. So this leads to another kind of idea then of designing ontologies by reuse, right? So the idea would be, we use these disagreements about semantics as an opportunity to not only formalize our own intended semantics, using ontology, but also as a way of designing a new ontology by articulating any differences. So rather than starting from scratch every time, right, having people, what we're doing is we're having people design their own ontologies through dialogue with other people and their ontologies. So if we kind of say, well, I think an event is something that's instantaneous, right? What do you think? Oh, an event is something that is that has some kind of duration. Oh, when I use the following concept for having something that has duration, I call that a process, right? And so now we can say, oh, I see what you mean by event, or is what I mean by a process. And it's that dialogue that can really achieve the interoperability among people, which can then get reflected in the interoperability of, say, their underlying data models. But we're using ontologies as a way to do this. Again, we're using ontologies as a way to identify similarities and to articulate differences, and empowering people to design their own ontologies in such a way that they are really interoperable. So this ontology reuse methodology then, we use competency questions to kind of specify each ontology's semantic requirements. And we use the Katsumi reuse operators as a way then of kind of changing our ontologies in order to kind of reflect what these differences are. So if an ontology is too strong, we extract a subset of the axioms. If the ontology is too weak, we extend it or combine it with another ontology. And we have found this methodology to actually work quite effectively. Again, what we're doing is leveraging each other's experiences and building our own ontologies. So this leads to the next question of ontology acquisition, right? Now, we have various methodologies for doing ontology acquisition. The problem is that they can be very labor intensive. And so if it takes like 1,000 work hours to come up with one axiom of an ontology, that's a pretty heavy investment. Is there some way we can bring the hours per axiom metric down, and so we can have more effective ontology design? And so in particular, are there any semi-automated techniques that we can use to design ontologies, right? And kind of keeping in mind this idea of empowering people to design their own interoperable, reusable, shareable ontologies. So how can we assist people in this identification and extraction of the intended semantics that they use informally, right? And that's kind of in their minds. But how often could you often say, well, I've embedded everything that I want to do in my data model. So another alternative perspective of this would be to say, can we actually identify the intended semantics of our data models within the enterprise? And so that leads to what we call the Hashemi Procedure, which was kind of developed within the Semantic Technologies lab. The idea is to use what we call, say, clean data sets as examples, and data sets with quality problems to be counterexamples, right? So the idea being that I may not know exactly, I can't quite articulate, axioms. I'm not maybe, I don't have a lot of logic background, but I know like what the right kind of data set should be, right? So that I know what a product is and like what the dates are. And so I can give you like, here's a set of transactions, and this would be what I consider to be a good set of transactions related to product delivery. And so we use these data sets as a way of identifying what the ontology should be. The idea is that the examples are what are called intended models. So these are kind of correspond to these kind of satisfying interpretations that you would want your ontology to satisfy. And the counterexamples are the unintended models. And what we've implemented is a way of navigating through an ontology repository in such a way as to find the best matches to ontologies within the repository. So again, we've used this quite effectively to identify ontologies and to explicitly axiomatize them in a way that matches everyone's intended semantics. Okay, now that we have these ontologies, right, one of the promises that we have as kind of ontology engineers is that, well, now once you have ontologies, you can actually do a lot of new things with them. So the question here could be, what's this return on my investment in designing ontologies? I might have put a lot of effort into doing this design. Does it buy me anything, right? How can we actually leverage the existence of ontologies to assist an enterprise? And I'll just kind of quickly go over 3 applications here: semantic augmentation, question answering, data quality. So first, semantic augmentation. What we're doing with that is effectively taking existing algorithms and extending them, kind of infusing them with ontologies. So as an example, you can see ontology-based search, right? That you can You can have existing information retrieval algorithms, sorry, and by using ontologies, even something, you know, as a pseudo semi-ontology, quasi-ontology like WordNet, you can kind of refine your search space and guide the search. Another example is ontology-driven software, where you can generate Java classes from an ontology and use this as a way of implementing the system, or even exporting data models from ontologies, you know, even an ER diagram into Irwin, and so you can go from ontology to data model, and you can be guaranteed your data model is what you want it to say. The second sort of benefit of ontologies is question answering. And this is just a little simple example, a toy example that we have, where I have professors teaching courses, professors are instructors. So I have a bunch of axioms on the left that are talking about relationships between professors and courses and instructors on the next slide here. And over on the right-hand side, you can see different facts, right? Alice lectures Math 456, which is a science course. Bob teaches MIE 123, which is an engineering course. And there's a set of questions you can see at the bottom of this slide. The interesting thing is you cannot answer any of those questions by just using SQL queries on the data, right? There is nothing in the data that tells me that Math 456 is a course. The data tells me it's a science course, but it doesn't say it's an actual course. Nowhere does it say whether or not Alice is a professor, right? And so there's no, or that Bob says is an instructor, right? And so you can't actually just use an SQL query. You need to use the background knowledge of the ontology in order to answer that question. There's like little informal proofs there. Okay, so then the third sort of benefit, a third application of ontologies is in terms of data quality. Right, so data quality being the problem where, you know, I may have inconsistencies within my data. And so we can see on the next slide an example of this, where in my data, and this is kind of the same example, except here there's a little piece of data has been added that Bob is a student. Now again, just from the data alone, I can't tell whether or not there's any consistency in the data, right? I can't write an SQL query to find the data quality problem. However, right, note that previously we've deduced that Bob is a professor. Now, if Bob's a professor, we can deduce that Bob is not a student. However, we have a fact in our database that says Bob is a student. We have an inconsistency here. So one or more of these facts are incorrect. You know, either Bob is not actually a student, or Bob does not teach a course, right? Maybe that's the fact that's wrong. So you can use this as a way then of identifying, you know, where is our potential problem, right? And so the idea is you can actually use the proof that there's an inconsistency as a way of identifying what are the potential data quality problems. Okay, so just one more slide here, and just to kind of wrap up on some ideas of, you know, I've talked about how this idea of kind of empowering people to build their own ontologies through articulating their differences, identifying their similarities, but really, like, what skills do people need in order to effectively design ontologies to actually deliver this vision? Now, I've given a couple of like you know, mini courses in a few different actual companies to try to address this challenge, and it's been very interesting in kind of doing this sort of tutorial style, because it's been interesting to see what skills are actually useful. So first of all, a data modeling background is really necessary. This idea of kind of conceptual modeling, identifying, you know, what are the kinds of things in my domain, what are the relationships between them. Those basic skills of data modeling really go a long way, right? I think if you have a good foundation with that, you're getting those skills of kind of carving up a problem, carving up a domain into identifying what those fundamental things in the relationships are. Then I think another skill is to be able to have kind of ontological analysis, to be able to kind of discern, you know, when does something make sense, and you know, am I making some kind of false assumption? And then finally, mathematical logic. Now this can often sometimes be intimidating, but really it's not. So I've been able to really deliver and have people get to the point where they can actually use automated theorem proving software after just, you know, kind of 5 sessions of dealing with logic. And so to me, first order logic is much simpler than differential equations, for example. And so I think that that's a skill that's not only necessary, but it's also achievable. So that's it for me today. Just on the summary slide here, I just want to emphasize, again, ontologies are not simply ways of representing knowledge. It's also the basis to help people communicate with each other and work together on supporting semantic integration. I'll say once we have these ontologies, we can support all kinds of new applications in question answering, software design, data quality, all that kind of stuff. So thank you very much for the time. And I believe there's a kind of a little chat room later on, or a meeting room where we can I can answer any questions or have any other kinds of discussions that people would like to have. So thank you.